Welcome everyone to this comprehensive explainer on sunken slabs. Whether you're a homeowner dreaming up your perfect house, an architecture student, a site engineer, or a contractor, you're in the right spot. Today we're taking a pretty technical civil engineering concept and making it super accessible. We're going to look at the actual structural magic that keeps modern buildings looking sleek and, most importantly, completely leak-free. So grab your notepads, we're covering the whole shebang, from basic engineering principles to exactly how this gets executed on a real construction site. Okay, let's dive right into this. We've got a great roadmap today broken down into 5 quick sections. First up, what exactly is a sunken slab? Second, the pros and cons. Third, the key construction steps. Fourth, waterproofing and quality checks. And finally, common site mistakes and expert tips to avoid them.
All right, Section 1. What is a sunken slab? Let's look at the fundamental engineering solution.
You know that totally universally dreaded nightmare of a leaky bathroom ceiling? Or walking into a gorgeous room only to see ugly pipes hanging overhead? To solve that, we have to look at the engineering fix. A sunken slab is, quite simply, a concrete floor slab cast intentionally below your normal floor level. Think of it like a structural depression, almost like a giant tub built right into the floor. The depth of this tub usually ranges from 150 to 450 millimeters. And that specific number isn't random. It's carefully calculated based on the building's design. This really clever drop in elevation gives us the exact physical space we need to tuck away all that modern plumbing without having to raise your overall floor level. And this comparison perfectly illustrates the difference. Imagine a normal slab. It's just a uniform, flat structural level. But when you add plumbing to that, you're stuck either looking at exposed pipes hanging below the ceiling, or you have to aggressively cut through the concrete, which, let's face it, is terrible for structural integrity. Now compare that to the sunken slab. It gives you this lowered zone where all those pipes are completely concealed. Once that void is filled in, you are left with a totally seamless floor finish. For any wet area in a building, it's just visually and structurally vastly superior.
So, where do we actually use these things? Well, you're going to find sunken slabs in spaces where controlling water and hiding pipes is an absolute must. We're talking bathrooms, toilets, washrooms, utility areas, and dedicated shower rooms. Literally, any zone in a building that relies heavily on plumbing networks needs this exact engineering technique to keep water from sneaking into dry areas.
Moving on to Section 2, Pros and Cons. Let's weigh the engineering trade-offs.
Now, what's really interesting about this is that every single engineering decision involves a trade-off. You're always balancing incredible benefits against actual on-site challenges. The advantages here, they're fantastic. A sunken slab hides all your plumbing, physically stops water from spreading because of that drop level, gives you much better drainage, makes maintenance access easier, and leaves you with that pristine professional finish. But there is a catch. That seamless look absolutely comes at a price. It means higher construction costs, a much more complex execution process. You absolutely need highly skilled labor, and it demands unforgiving, totally strict waterproofing. Basically, if you want the aesthetic and functional benefits, you've got to pay for the expertise to do it right.
Okay, Section 3, Key Construction Steps. We're going from marking right through to finishing.
Actually executing a sunken slab on a site is a pretty complex, multi-step process. But to make it easy to digest, let's break its life cycle down into 6 main phases. First, we start with structural marking and steel fixing, getting that reinforcement perfectly aligned. Next up is installing the formwork and putting in sleeves for your electrical and plumbing lines. Stage 3 is the big one, RCC concreting, followed by plenty of curing time. Once that concrete is rock solid, we hit Stage 4, laying out the actual plumbing inside that sunken tub space. Stage 5 is rigorous waterproofing and leak testing. And finally, Stage 6 is filling that remaining void with a lightweight material, laying down a protective screed, and finishing it off with your floor tiles.
Now, I want you to look at that entire process and ask yourself, what do you think is the single most critical phase out of all of them? Seriously, you could use the strongest concrete and the absolute best steel money can buy, but all that structural strength means absolutely nothing if you mess up this next crucial step.
Which brings us to Section 4, waterproofing and quality checks. This is all about protecting the investment. Yeah, the answer to that question is absolutely waterproofing and quality checks. This is the grand climax of the construction phase. It's what actually protects the homeowner from insanely expensive, damaging leaks a few years down the line. Look, waterproofing is essentially a race against water, and you have to win. The process demands high-quality materials right out of the gate. It requires meticulous membrane application across the entire sunken area, followed immediately by laying a protective screed layer so that membrane doesn't get punctured by someone's boot during the rest of the build. But the real standout here? That last point, the flood test, also known as a ponding test. You literally fill the sunken area with water and just wait. You wait to see if it leaks. It's absolutely 100% mandatory.
So the major takeaway here is this quality checklist. If you're a site engineer or a contractor, listen closely. Before you finalize that slab, you must verify the reinforcement is perfectly placed and that you have proper concrete cover. You've got to confirm high-quality concrete was used and that it actually got adequate curing time. You have to conduct pressure testing on the pipes, execute that final flood test we just talked about, and meticulously check that the floor slope is directing water exactly toward the drain. Skip even one of these checks, and the whole system is going to fail.
Let's transition to Section 5, Common Mistakes and Expert Tips. This is all about real-world site execution.
Theory's great, right? But real-world site execution is where a project either shines or turns into a massive, expensive headache. Take a look at how sloppy execution can totally ruin all the benefits of a sunken slab. If you do a terrible job with the waterproofing, the impact is severe, incredibly costly leaks into the rooms right below you. If you get the floor slope wrong, you're looking at constant waterlogging. If you rush the concrete pour and end up with honeycombing, those porous, ugly voids in the concrete, you've just created a severe structural weakness. And if you accidentally block the inspection points when you're laying down the tiles, you've just made future maintenance completely impossible.
So, for the professionals and engineering students tuning in, here is a golden rule for you. Adhering to official IS standards is completely non-negotiable. You must always follow the latest Indian standards, the IS codes, for your RCC construction, concrete quality, waterproofing, and plumbing. These aren't just polite suggestions, guys. They are the literal blueprints for good construction practice. They are what guarantee both safety and long-term durability.
To wrap up our core takeaways, try to keep these practical tips at the front of your mind on your next job. Always map out your plumbing layout before you pour the concrete. Never, and I mean never, skip the leak testing. Don't cut corners. Use high-quality materials. Make sure you have a proper slope pointing directly to the floor traps. But above everything else, supervise the work at every single stage. Rigorous, eagle-eyed site supervision is the absolute key to delivering a high-performing, long-lasting sunken slab.
And that brings us to the end of our explainer. I want to leave you with this message directly from our source material. For quality construction, technical knowledge, and reliable civil engineering advice, follow engineer Abubakar Bavakati. Bavakati Construction's Hunagund provides quality construction services for your dream building. For more useful civil engineering videos, subscribe to their YouTube channel. Thank you. Before you log off today, I want you to just look up at the ceiling above you right now and ask yourself, is the engineering hiding up there strong enough to stand the test of time? Keep asking questions, keep building smart, and we'll catch you on the next explainer.